don't know what this is basically a question and answer video web stream from Dev Mastery. So Dev Mastery is a project that I started, so I'll introduce myself in case you're not sure who I am or you stumbled in here. So my name is Bill Sourour. I've been professionally programming and architecting mainly web applications since the mid-90s, since about, I think my first paid gig was back in 1994. I started a project that I call Dev Mastery. And the idea behind it is it's a way for me to sort of give back to the developer community. And what it is right now is basically a weekly newsletter that I send out through devmastery.com. So if you stumbled onto this video or stumbled into this live stream, and you don't know anything about me or who I am, there's a quick summary. I invite you to go to devmastery.com, sign up for the newsletter. I send out interesting links and interesting information every week. It's not I don't get paid for it. It's not, I'm not sending out sponsored links or anything. It's just things that I find useful and helpful for me. So I gotta say, I was absolutely blown away and overwhelmed by the response to this webinar. So basically, I've received almost 100 questions from people with a variety of backgrounds. So you can see there, in terms of demographics, about somewhere between a quarter and a third of the people submitting questions are people who are just learning, who are just getting into the into programming and into web application development. Another roughly third or so, or roughly quarter or so, are people who have between 0 and 2 years experience. So about about half the people who submitted questions have been at this for less than 2 years. But then people run the gamut. So we've got questions from people who've been at this for 5 to 10 years, even questions from people who've been at this for over 15 years. So they were really really good questions. And obviously being sensitive to time, I can't individually answer 100 different questions. So what I've done is I've sort of grouped them into topics, and I've taken common or similar questions and sort of generalized them so that I can get to as many of them as possible. And just so you know, the way I'm intending to run this is I'm going to just run through these various topics and discuss each one, and then at the very end, so at the end of the webinar, I will take your follow-up questions. So if you have questions as we go, just please hold them to the end. I don't want to be looking at the chat the whole time and be distracted by the chat. I want to be able to flow through and get to all of the questions. So again, please be patient. If you have questions, I promise you I will stick around at the end and I will answer as many questions, as many follow-up questions as I can. In the meantime, obviously feel free to chat amongst yourselves. That's fine. I'm going to kind of ignore the chat as we go. So when we talk about the topics that sort of emerged, roughly half, actually exactly half the questions were around this idea of learning. So people are very, very interested to hear, what they should be learning, how they should be learning it, and where they should be learning. So we're going to talk quite a bit about that. Then about a quarter of the questions were around this idea of code and how to design and structure applications and how to design your code and what makes a good design and what sort of general practices are favorable when writing and structuring code. And then another roughly quarter of the questions really had to do with career type of advice. So things like, how do you know when you're ready to get a job for people who are just starting? How do you know when you're ready to move jobs for people who've been at this for a while? And a big question was, how do you deal with sort of unreasonable demands or unreasonable requests, either from clients or from managers, etc. So we're going to touch on that as well. And the approach here is because I'm covering such a broad spectrum of topics, what I'm going to try to do is for each topic, I'm just going to try to give you the most critical, sort of the key points, and I'm going to point you in the direction of other resources as well that can help you and that will have a further elaboration. And based on how this goes and the feedback I get, I might do specific videos or web streams about specific topics where I dig even deeper. For now, this is just going to be pretty broad. And again, like none of the links that I'm going to give you here are anything that I'm getting paid to give you, or nothing is sponsored. It's just me trying to share what I think is good and worthwhile, and hopefully is helpful. Okay, so let's dig into the first topic, which is learning. So by far, the biggest question I got was some form of or I should say the most popular question I got was some form of this: what should I learn? And it came in the form of, what language should I learn? What framework should I learn? What topics should I be learning? And so before I give you just kind of like very specific answers, I want to give you a framework or a way of thinking about this question so that you can begin to answer it for yourself. So it's kind of the old, give a man a fish versus teach a man to fish analogy. So the way I think about learning is that it's an investment. So regardless of whether you're paying to money to learn or not, you're investing your time. And so when I think about what types of things I should be learning, I think in terms of a return on that investment. So what is going to give me the maximum return on the investment of my time learning? And what I found is there are basically three types of things that have what I would consider a high return on investment. And so the first type of thing is anything that has what's called broad applicability. So in other words, you learn this thing once, and then having that knowledge, you can then apply that knowledge to many other aspects of coding and really in some cases of life. But you basically want to invest in things that are broadly applicable so that you can reuse that knowledge in multiple contexts. The other advantage of learning things that are broadly applicable is then it gives you a baseline or a foundation from which you can learn other more specific things. So you basically will always have a frame of reference and a foundation over top of which you can gain greater knowledge. And I often talk about the fundamentals of application or software development as being something that has broad applicability. And I'll talk about that in a second exactly what I mean by that. I'll give you some recommendations. But so the first thing is anything that has broad applicability, that should be one of the first things that you're looking for in terms of investing your time in learning. The second thing I would say is things that have high marketability. So when I say high marketability, it's a skill that's highly in demand. So that is probably the clearest example of return on investment, because obviously if you're learning a skill that is in high demand or a niche or a specialization that is where the supply is much lower than the demand, then that means the market for it's going to be very good, and having that skill is going to allow you to move up, and it's also going to allow you to make a larger income. If you're freelancing, charge higher rates. If you're an employee, gain a higher salary, gain a more senior position. So that's the second criteria. So first is broad applicability, and second is high marketability. And then the third criteria is probably a little bit controversial, but I stick by it. It's the idea of enjoyment. So I think things that may not be broadly applicable and may not be highly marketable, but that you have a passion for or a keen interest in, are still worth your time. And if you just the act of learning is helpful, and if you don't take any time to learn things just out of pure interest or out of pure passion, then what's going to end up happening basically is you're going to get demoralized and you're going to stop wanting to learn. So that's sort of the third criteria, and that's really how I look at figuring out what I should learn. It's those three criteria, more or less in that order. And so when you talk about specifics or specific recommendations, so when we think about broad applicability, there are two kinds of things that have broad applicability that I think are a must. So one is the what are called the Gang of Four patterns. It's from a book called Design Patterns, and it's Patterns of Object-Oriented Design. And I should tell you, by the way, all of these recommendations that I'm giving you, these links, these resources, these books, etc., I will put in the description of the video. So when I send you the replay, you'll have the actual links, names, etc., all in the video description. So if you miss anything, don't worry. I'll make sure that you're well covered and that you've got access to these links and to these recommendations. So things with broad applicability are the Gang of Four design patterns. There's really two places where you can learn those things. Well, there's many places, but the first place is the source material, which is the original book called Design Patterns. The other place is a place called Do Factory, D-O Factory, and that gives you a bunch of examples of all of the design patterns, both in JavaScript and in C#, so you can see actual live examples. It's kind of my cheat sheet website that I've been going to for many, many years, where if I'm confused or I'm not sure, I don't remember a particular pattern, I can go there and look it up and get an overview, and then see an example implementation. And then the other thing is some of the basics of computer science will have a high and broad applicability. Common problems, things like caching, for example, things like filtering, sorting, etc. And the best way to learn those in an approachable way where it's not super academic, there's two like awesome resources. So one is a course from Harvard called CS50, and this course, it's a real course that is given by Harvard University that Harvard students can take, but they make it available absolutely free online, and it's totally worth, even if you don't do all the exercises, etc. It's just worth auditing. They update it every year. The quality is phenomenal, and it's taught in a very engaging, entertaining, fun way, and you can learn a lot of the sort of computer science fundamentals. So if you're brand new to coding and you're mired in sort of this just learning kind of syntax and data structures, and you're not really sure what's going on or how to wrap your head around it, you may want to take a step back, look at CS50, and then come back. You need a good balance. You can't just learn all practical or all theory. You have to have a balance of both. So that's in terms of fundamentals. If we talk about what language you should be learning, the short answer for that is if you don't know it, learn JavaScript. And if you think you know it, learn JavaScript, because you probably don't know it. The reason I say that is because it really satisfies a lot of the first criteria as well. In terms of JavaScript is you can use it on the client, you can use it on the server, you can use it on make desktop apps with it, you can make mobile apps with it. It just has a tremendous amount of broad applicability. It's also a highly marketable skill. It's hard to find a web app developer posting, even if it's for a backend developer, that doesn't have JavaScript somewhere in the description, either as a must-have or nice to have. So JavaScript 100%. And where you could go to learn JavaScript, first there's a series of books by Kyle Simpson called You Don't Know JS, and that's available 100% for free online through a GitHub link, which I'll put again in the video description. So You Don't Know JS is a great way to learn JavaScript. There's also a couple of online courses by a gentleman named Wes Bos, who's a fellow Canadian. He has a free course called JavaScript 30, which is basically 30 JavaScript projects in 30 days. So it's a good way to kind of apply your knowledge. And he has another course that specifically deals with ES6, or ES 2015 is the real name, which is the version of JavaScript that came out in 2015 that was a radical, it added a lot of features to the language. It was a real step forward for JavaScript. And it is, well, we're actually at ES 2016 now, so we're at ES 7. So it's very much worthwhile catching up and learning that stuff. It's very important. In terms of frameworks really depends on the market, the job market where you're in. But a couple of guidelines are, try to invest in frameworks, that are basically supported by large companies and that are used by large companies. So obviously the two main ones that come to mind are Angular and React nowadays. But you also need to make sure that you're and those are obviously front-end frameworks, but also in terms of stacks, look for stacks that have wide adoption and that are well supported by large companies. So the best thing to do there is go onto your job sites and go in there and take a look at your job market and see what are the frameworks that are in demand, what are trending up, and then those are worth learning on the strength of basically on the strength of their marketability. And then in terms of specific topics and things that you should learn about in terms of things that are coming up in the future that I see as trends that are worthwhile. Obviously, there's a big movement towards functional programming. It's good to have some functional programming as part of your bag of tricks. I think you know, it's very sort of trendy to say functional programming. I think the aspects of functional programming that are useful is the idea of writing declarative style code as opposed to imperative style code. So try to look that up, like declarative code, and then also the idea of higher order functions and the idea of pure functions. And so if you're not sure what I'm talking about, there's a series of articles on Medium called "So You Want to Be a Functional Programmer" that does a good job of introducing you to the various concepts of functional programming. And then if you want to deep dive into functional programming, there's a free book online, and it's Professor Frisby's Mostly Adequate Guide to Functional Programming. It's a very entertaining book, and it really goes deep into functional programming. So that's worth learning. The next thing that I think is worth learning that is going to be a trend soon, if not already, is this idea of reactive programming, or and specifically the reactive extensions library. So if you go to like reactivex.io, this is a library that is actually spans across multiple different languages. So there's implementations. It doesn't span across languages. There's implementations of it in every language. So the implementation for JavaScript is called RxJS, but there's implementations for Python, for Ruby, for PHP, for Java, for C#. There's just, it's been implemented by basically every major language. It has major support from Microsoft. It has major support from Netflix, and it is a really new way, in a way, of thinking about how to work with data and thinking about data in terms of streams and in terms of events. And it combines, I was talking about the gang of 4 patterns before. This is why it's good to know those patterns, because it combines something called the observer pattern and something called the iterator pattern. So a couple of weeks ago, I actually sent out in my newsletter some links to a fellow by the name of Jafar Hussain. He's got some videos on YouTube that sort of explain, give you an overview and an introduction to what reactive extensions are and to this new thing called an observable. And what an observable is, and that it's actually there's a proposal to put observables in the JavaScript or in the ECMAScript specification, so it'll actually become most likely will become part of JavaScript. It also is already part of the .NET framework. I think it's already part of .NET Core. So this is something that is definitely worth the time to invest and learn, and it's very useful. So I would definitely recommend looking into that. And then the other thing, and I'm sort of guilty of having not pursued this enough myself, is this topic of machine learning and AI. So that's something that you should at least try to get familiar with. And that's sort of on my list as something next. So I don't have a great recommendation yet for resources. I haven't dug into it yet, but that's definitely, in terms of specifics, stuff that I would look at. So the next question around learning that I got is basically how should I go about learning? And there's really sort of 2 aspects to that question. So one aspect is, what techniques to use to learn, and another aspect is motivation. So how do you stay motivated and keep yourself in the game? So in terms of techniques, what I would say is you need to apply your learning early and often, just as a general guiding principle. So look for ways to apply any new thing that you've learned as early as possible, and you need to do that repetitively. So don't wait until you've learned a whole stack of new things before starting to try it. Start to try it right away. And so specifically, what I do is if I'm trying to learn something new, and let's say I'm doing like an online tutorial, for example, so it'll walk me through, typically the tutorials will walk me through a series of steps. Well, they'll give you some code to do, you'll do the code and you'll get an expected result. Before I move to the next step in the tutorial, what I'll do is I'll try to make a change to whatever code it told me to write, and I'll try to predict the impact of that change. So really, really rudimentary example just that everybody could relate to is, if you're learning Hello World in a particular language, so you're going through the tutorial, the first thing it's taught you is how to print Hello World on the screen. And so you say, well, what if I wanted to write Hello Bob? Well, what I have to do? So you make a change, you run it, and you see that, okay, by making that change, it now printed Hello Bob. So it gives you some confidence that you actually understand what it tried to teach you. Obviously, that's really rudimentary, but I'm just trying to give you a universal universal example. So try to apply the knowledge as soon as you get it. Try to sort of call your shots. That's really handy. I sent an article, I think a couple of days ago, about different learning techniques and what the science behind, what methods work the best. The thing that works reliably the best is spreading out your learning over time. So being consistent and spreading it out over time, and then this idea of testing. So when I'm talking about applying the learning in a way and making small changes and trying to predict your changes in a way, what I'm talking about is testing your knowledge soon after you acquire it, and frequently testing your knowledge. And you can also look up, if you're digging into a subject, you can look up common interview questions for X, and then see if you can start to answer those questions. Keep on testing yourself. So that's techniques, and that's kind of how I go about learning. In terms of motivation and staying motivated, I think the thing that seems to work the best for me is you need to have a community. So if you're just learning on your own and you've got no one to talk to, sometimes you can get into a rut. So you have to find a community. You have to try to learn with other people. Free Code Camp is a great place where there's a great community there. So it's not just the site of learning. There's a great community there. If you're working professionally, what you can do is you can develop a community and create a social aspect around learning in your workplace. So and one fun way to do that is sort of to issue challenges. Have a little pool with your coworkers and issue a challenge, like we're gonna do X by this date, or we're gonna learn X by that date. Have things like a lunch event or a lunch and learn event where you pick a cool topic or a cool video that you just learned, and you just share that with other people, or you watch a video together and then you come up with a challenge. Definitely a huge part of motivation is that sense of community. Another big part of motivation is, again, trying to apply what you've learned to something that you find useful. So try to come up with projects and things that you would be interested in, and where you can apply your learning, and at the outcome, like once you've completed that project or once you've built a certain component, you actually will be using it. So you find it actually useful. So that is what I would recommend there in terms of techniques and motivation for how to learn. And then the next questions I got were around where to learn. So should you invest in going to university, invest in going to school? Should you go to a boot camp? Should you do self-study? What should you do? So what I would say there is, if you're somehow in a position where you can get a formal education without going into debt, so you can go to college or you can go to university without amassing a lot of debt, then I would say it's worth doing that. I think that, I talked about before emphasizing fundamentals, etc. I think that formal study gives you a really, really good baseline. It's true that you don't have to do that. You don't have to have a formal education to be successful in this field, for sure. It's not an absolute requirement, but it's a very nice thing to have, so long as you're not putting yourself into a bad situation financially. So I know for most people that's not possible, but if you live in a country where university or college is free and you're young, you don't have massive obligations, that's would be my first choice. In terms of boot camps, I mean, I haven't been to a boot camp myself, but I've tried to help or mentor or tutor other people who are applying to boot camps. What I've found is a lot of boot camps, the barrier to entry is very high, because what they want to be able to do is they want to be able to report on very like glowing outcomes. So 98% of our students get work in this field, or some of them even say, we won't charge you any tuition, but we're so confident that you're going to get a job that you don't have to pay us until you actually find work, which sounds great, and obviously in many ways it is great. But what then they do is they set the barrier to entry really high, and they only accept people that are almost at the point where they could get a job today anyway, and they just give you that extra just an extra little boost. Sometimes they just give you an extra bit of confidence. They're good in terms of creating a community if you don't have access to a community elsewhere, but you're going to have to do a lot of self-learning before you can even get into a boot camp. And so I'm a big believer in self-study. I think that we live in an amazing time. I mentioned that Harvard course before. Well, imagine there's some, there's a bunch of teenagers out there somewhere in high school, busting their butts trying to get great grades and trying to get into Harvard, and you can just sort of from your computer sit there and audit a course. So I think self-study is the way to go, provided that you can find yourself a community, and that you can that you can find little projects to keep you motivated. And also a good thing is sort of commitment traps. So make commitments to others, and that'll keep you going and keep you motivated. So for me, this dev mastery thing is a great sort of commitment trap. So every week I'm committed to sending out links and resources and information and writing about topics. So that keeps me looking for and learning, so that I can share that learning with others. And so that's a good thing. The other thing I'll say too, for people who are further along in their career, who are looking for who feel like they're stuck in a rut. So there's two things. So one is, if you're looking to get deeper insight and understanding into the type of work that you're already doing, a good thing to do is try to mentor and try to teach others. And by teaching others, you're going to solidify and you're going to learn more yourself. You're going to receive questions from others that will prompt you to look into things and to gain a deeper understanding of whatever topic you're in. If you've been working for a while and you're interested in sort of been repeating and doing the same thing, and you want to try something new, you need to sometimes you need to really like break your routine. So at one point I was very heavily involved in the world of .NET. I was doing lots and lots of C# programming. And so I decided I decided I wanted to go into the open source world. I got myself a Mac where, at the time, it's different now, but at the time you couldn't even run .NET on it. And I started working on hybrid mobile applications, because I was fascinated by the mobile space, and I was fascinated by sort of all of these frameworks that were coming out in libraries and JavaScript and etc. And so I kind of broke my routine, and I found some interesting projects, and I started to do that. So that's an important thing to do in terms of your career, just to kind of stay fresh. The other thing I would say about learning, and it's a topic that comes up often, is this notion of, oh my goodness, there's so much to learn. How will I ever learn everything, or how can I possibly keep up? And so two things about that. So first of all, you're never going to learn everything. That you need to disabuse yourself of this concept that there's going to come a day when you're going to say, okay, I'm done. I've learned everything there is to learn about software development, or even specifically web application development. It's not going to happen. There's too much to learn. So that should reduce some anxiety. And then the next thing is, so given that you can't know everything, if you follow the guidelines I gave you in terms of choosing what to learn, then you're going to find that you're going to make progress in a very good direction. A lot of so-called fads or new frameworks or new things that come out are just not going to matter that much over time. They'll be popular for a while, and then they'll go away. And especially if you're working, if you find yourself working in a company that's not necessarily a startup, or maybe it was a startup when you started, but it's now got some traction, or it's been around for a while, you'll see that they can't, organizations can't really afford to keep spinning on a dime. So they can't, just replace their entire stack and go to a brand new technology every month or every couple of weeks, even though all this new stuff keeps coming out. So I wouldn't worry too much about, learning every new thing. I would worry about applying that test that I gave you earlier in terms of what to learn. And I would also say that if there's a stack or a set of technologies that you use on a daily basis, when new versions of that come out, you should think about learning those. So let's talk about code design and architecture. So a bunch of questions came up there. So I got multiple variations of basically this question, which is what makes a good design. So basically, a good design, the litmus test, what I would say, a simple way of thinking about it is, the best design is any design that is easy to change. So given the choice between sort of two options, always pick the option that is easiest, that's going to be easiest to change later. And the reason for that is because change is basically the only constant. And so you know that over time, customers, clients, etc., are going to want new features. Over time, you're going to discover bugs. You're going to discover things that don't work as expected. You're going to have some assumptions that you made are going to be wrong, and your code is going to break, and so you're going to have to change it. Over time, your understanding of the requirements is going to evolve, and you're going to have to change that. Over time, you're going to find optimizations. You're going to find things that may not be performing as well, and there's ways to optimize it to make it perform better. Over time, new libraries are going to come out, new versions of things are going to come out. So all of these things are going to cause you to have to change your code base. And so the best design is that design which is easy to change. And so the two things that influence your code being easy to change is, one is the idea of making reducing the amount of dependencies in your code. So frequently you get into a situation where you're looking at a code base and you go and you change one thing and you break 10 other things. And even worse, sometimes you could change something and something completely unrelated in the code base changes. So that's an indication of poor design, bad design, because there are too many dependencies. Your code is too tightly coupled together. So that's one thing. The other thing that makes code easy to change is it has to be easy to understand, easy to read, easy to understand. There are frequently in large code bases, there are areas of the code base that certain developers, people don't want to touch. People don't want to look at. They're just scared to touch anything in there because they're worried it's going to break things. And oftentimes the case with that code is not only is it maybe poorly designed in terms of dependencies, but it's also hard to understand. So nobody understands this code, so nobody wants to go near it. When we talk about what patterns to use to end up with code that is easy to change, what I would tell you is a couple of patterns that I really like. One is this idea of S.O.L.I.D architecture, which is advanced by a guy named Bob Martin. So I did a thing a while ago on clean architecture. This is it's related. It's called S.O.L.I.D is an acronym for a bunch of principles. And so I mean I could do a whole session just on that, but just to try to give you an overview very quickly. The S is for single responsibility. So that means that your classes or your modules need to only deal with a single concern. Or another way to say it is there should only ever be one reason for a module or a class to have to change. So that's the single responsibility principle. The O is for something called the open-close principle. The idea of that is that your classes or modules should be open for extension and closed for modification. So you should write code that can be extended in the future without that code itself having to be changed. And so that seems tricky to do, but it's actually, if you're using interfaces, if you're in a strongly typed language, if you're using interfaces and passing interfaces around, then what you can do is you can write new implementations of a given interface, and the code that leverages that interface will suddenly be extended without you having to change that code. If you're in a dynamically typed language or a weak typed language, if you're writing something like JavaScript, you actually get this sort of for free. So because JavaScript does not have out of the box strict types, what you can do is, as long as if you're not importing a module, but rather you're injecting a module, or you're passing in a dependency rather than statically importing the dependency, then so long as that dependency satisfies a particular interface, so long as it exposes the functions and properties that your code expects, you can pass any object in there, even an object that you come up with later, and you can have new implementations of a given function on that object. And so suddenly your code is you're extending your module, you're extending the capabilities of your module without actually modifying the code itself. So that's essentially the open-close principle. And that's if people come from a classical OO background or coming from strongly typed languages, they're sort of turned off by weak or dynamically typed languages. I certainly was when I first started, when I first when I was looking at JavaScript, I thought it was, a disgusting language that was super Mickey Mouse, and clearly it's going to be super error prone because it doesn't have all of the strong typing. And I've actually come to a point. Well, first, JavaScript has evolved, and lots of things have been improved in it. But also, I've come to a point where I actually really appreciate dynamic typing and weak typing, and some of the ways that can help you achieve this loose coupling. So then the L is for something called the Liskov substitution principle, which comes from an idea in math. But basically, the idea is that you should be able to replace any concrete class or any object with another object that implements the same interface without, and your code shouldn't break. So if you're implementing the same interface, you should never do anything that would if someone is calling that interface for one concrete type and then calling the same interface for another concrete type, it should never break. So that's called the Liskov substitution principle. The I is for interface segregation, and so the idea there is you should really write your APIs or write your interfaces or write the methods that you expose on a class or the functions that you expose on a module should be specific. And so in that case, you basically have a specific interface per domain, which is another thing that I'm really into, is this idea of domain-driven design. And so you should have avoid super generic APIs where your only public method is something just called get data. And where your concrete implementation is just get data. You have to make your interfaces a little bit more specific, and so you have good interface separation across domains. And then the D is for something called dependency inversion. So it's the idea of your typically speaking, a high-level module is going to have a dependency on a low-level module. So if module A calls module B, in a traditional sense, module A now needs to know about module B. So module A will then import or use module B, and now they're tightly coupled, and there's a dependency there. And so what you want to do is you want to make it such that module A doesn't have to know anything specific. It doesn't have to specifically know or reference or depend on module B. And the way that you do that typically is through something called dependency injection. And so the idea is that instead of importing the module itself, what you do is you inject module B into module A. And then another way to do that is if you're using a strongly typed language that has interfaces, is instead of importing the concrete type, you just import an interface definition. And so then you've now decoupled the modules, and you've essentially inverted the dependencies. So module B depends on the interface, and module A depends on the interface, and your dependencies going backwards. Anyway, again, S.O.L.I.D is something that you could spend a long time on. I will put a link in the video description to some other resources for S.O.L.I.D design and for domain-driven design. I got a question that was specific about adapters versus dependency injection. So somebody asked me, well, if I'm using a dependency injection, should I have do I still need to have adapters? So both dependency injection and adapters help you in terms of loose coupling or of separating your code. But the difference is that an adapter is basically allowing you to use incompatible interfaces. So you can, if you have an API definition and then you want to use a library or something that has a different API definition, the adapter basically converts from your published API definition to the library's API definition. And so adapters are really, really useful. I have a whole other webinar where I kind of go into them a little bit. Adapters are useful in two ways. One is you can delay or defer the decision about which specific libraries to use to implement certain functionality. So you can implement the API that you think makes the most sense for your application or for your specific domain. And then later, when you decide on a library that implements that, you can change that stub, if you will, to an adapter. The other thing is an adapter can isolate third-party dependencies. So if you write an adapter for a third-party library, and then you have everything sort of reference the adapter, or you inject the adapter, then when the third-party library changes, you just have to make changes in one place, which is in the adapter, so it makes your code a little less brittle. In terms of how to structure your code, and in terms of how to name things, most of the time what I see is code that I would actually invert the structure of the code. So the structure of the code is sort of inside out. And what I mean by that is it's very common where I see projects that are laid out by sort of type. So if you think of like something like MVC, right? So you'll have a high level package or folder that's called models. And inside there you'll have, customer model, product model, order model, and then you'll have a high level package or folder called views, and you'll have customer view, product view, order view, and then a high level called controllers, etc. And so what you've done is you've split a domain across multiple different packages and folders, and then you've bundled them together with other not necessarily related domains. So I would actually invert that. I would make your top level package or your top level folder be product, and then inside there I would have product models, product views, product controllers, and if you're on the front end, I would be the CSS, the images, everything that you need in order to implement the features of that particular concept or that particular domain or entity is grouped together, so that you don't have it spread out across your code base, and so that you can you can almost hit one. If you're working on a feature, you're working within one sort of top level folder, and everything that more or less that you need to do for that feature is bundled underneath that folder. And so it's basically turning a lot of structures that I see inside out. The other benefit of that is if you structure it that way, then when someone comes onto the code base that doesn't know anything about it, it becomes really obvious from the structure of your code base, from the names of the packages and the folders, exactly what the code does, what the nature of your application is. And then, of course, a part of that is naming. So in terms of naming, you basically have to, you want to come up with names that are very obvious about what your particular function or what your particular module does. And the best test for that is once you've come up with a name, tell someone else the name and ask them just based on the name what they think it does. And if they can tell you, give you a description that's exactly or very close to what you intended, then that's probably a good name. But naming is hard, there's no question. And also if you find yourself where you can't come up with one name that properly encapsulates what it is that your code is doing, then probably your code is doing too much. And so you need to think about reducing it down. Okay. So in terms of what should you focus on first, I got this question quite a bit. Basically, the thing that you should focus on first is whatever aspect of your code that makes your application unique. So generally speaking, if you're writing custom code, it's because either you're trying to do something unique or you're trying to do something common in a unique way. And so whatever that is for your particular application, that's the code that you should write first. Because everything else, things that are sort of commodity code, like routing and authentication and encryption and error handling, etc., chances are you're probably going to use a library for it, and there's going to be lots and lots of information about that particular library or that particular problem that you're going to be able to find, and it's going to be easier to solve. So start on the hard part, which is the part that makes your code unique. Yeah, I'm trying to be sensitive to the time. I've got a lot of material to go through. Should I use TDD is a question I got. Absolutely. I'm a big believer in test-driven development. I think if you do test-driven development right, it will actually speed you up rather than slow you down. I think I see test-driven development done poorly often. And so what I mean by doing it right is you need to write the test first, but also you need to be testing the outcome of your code rather than the implementation of your code. So your test should be structured around the idea of, given this input, I'm expecting either this output or I'm expecting this state change, rather than your test being, using mock objects in your test, asserting that a particular function was called with a particular parameter, now you're testing the actual implementation, and that's going to slow you down, because that's going to basically cause you to have to change the test every time you find an optimization in the implementation, where really you should only be changing the test when your code actually needs to be doing something new. So yeah, definitely use test-driven development. I don't test private methods, and generally I don't test UI stuff, things that like HTML, CSS kind of stuff. I'm not writing unit tests for that kind of stuff on the front end. And what I've come to sort of a pattern that looks like this. So when I'm coding, this is what my screen basically looks like. And I know you probably can't read the code, but that's okay. You don't need to. Essentially, what's going on here is I've put it in, this is Visual Studio Code, so I've put it in kind of Zen mode. And I've basically got it so that I have no other distractions. And on the top left is my test, my unit test. And on the top right is the code that implements the that test, the code that satisfies the test. And so basically I write a little bit of the test, I save it. At the bottom, it's constantly running it's running and watching my code and running the test. So I write a small test, I hit save, my test watcher runs and the test fails. I go over, I write the code that satisfies the test, I hit save, I watch my test runner go green. So it's this idea of red, green, refactor, red, green, refactor. And so I'm coding this way all the time. I find it's absolutely the best way to code. You become very productive and you go very quickly that way. All right, so let's move on. Yeah, so in terms of recommendations, books, etc., Patterns of Enterprise Application Architecture by Martin Fowler is a great book. There's lots of online videos by Bob Martin and some other folks around design. So there's a video that I'll link to by Bob Martin that talks about solid design principles. He has a book coming out called Clean Architecture, which I think will be very good. There's a book called Clean Code by Bob Martin. There's a presentation by Dave Thomas that I included in a recent newsletter, and I actually posted it on the blog. So if you go to blog.devmastery.com and you go to top links of 2016 or best of 2016, you'll see a video there by Dave Thomas where he gives you lots and lots of good advice as well. Okay, so we're now at the career section, and please don't worry, I will absolutely answer your questions as at the end of this. If you have follow-up questions, I'm glad to take them. So let's talk about career. So one of the questions I get a lot is how do I know I'm ready? What skills should I have? What projects should I have created? And what do I need to do in terms of having a portfolio? A couple of things I would say there is you're probably going to be ready before you feel ready. For a lot of people, they have this sort of nagging self-doubt. So you need to go out there before you necessarily feel ready. But what you need in terms of skills and in terms of projects is you should have either contributed to real open source, or you should have built even if it's just for yourself, you should have built an actual working application. So you should have had the ability to build something on your own. That's not to say, so that means not having just sort of copy pasted from a tutorial and produced an output. You need to have built something on your own. Ultimately, what employers are looking for is they're looking for people who have a track record or who can demonstrate that they've solved the kinds of problems that they need to solve day to day. And so the best way to do that is to show off that you've actually built something real. So a project should be small, but it should be meaningful to you. So it should be something that that you would like to see in the world, or that you would find personally useful. That should basically solve a problem for you. In terms of portfolio, what I would say about portfolio, the bit of advice I would give you there is basically don't put things like a list of skills with like 90% good at this, 80% good at this, or 4 out of 5 stars at this thing. That's completely meaningless. Focus on what skills you use to complete what projects. So your portfolio is about a list of projects and what were the skills that you used to complete that project. And then also one thing that'll set your portfolio apart is focus on the business value or the value proposition of whatever you built. So focus on the actual problem that was solved by this particular project. Okay. So in terms of tech interviews, my best advice for that is I have an article that I ended up turning into an ebook called How to Win the Coding Interview. I'll drop a link to that in the video description, and that's really my best advice there. We're running really low on time, so I'm not going to go into it. I will, by the way, stick around and take all of your questions at the end, so don't worry. I'll be here. I got a lot of questions about freelancing. So what I would say about freelancing is there's a website called Double Your Freelancing by a fellow called Brennan Dunn that will give you everything you ever need to know about freelancing. The one thing to bear in mind is if you're freelancing, you're not just writing code anymore, you're running a business, and that is not for everybody. So make sure that you're comfortable with the idea of, having to market yourself, having to sell stuff. You're comfortable with the idea of having variable cash flow, so that you're not kind of guaranteed a solid paycheck every week. Money's going to come in and kind of in a sort of a boom and bust scenario. I got questions around, what about, how if I'm freelancing, how do I know that, or what do I do if I feel like I'm getting in over my head, or if somebody comes to me with a project that I'm not comfortable in? Part of freelancing, especially if you're getting your own clients and your own projects, is building up a network of other resources that can complement your skill set. So anything that you may not be good at, you need to find people that are good at that so that you can offer essentially more services and win more business. And in terms of rates, if you just go to wyourfreelancing.com, there's some great free advice there on rate setting, way better than anything that I could give you now. So the next one is a big topic. So it's basically how to handle unrealistic expectations and demands. And the first thing that you have to be aware of is your client, your customer, your manager, or whatever, they don't know. They don't know what they don't know. They're not technology experts. So they don't know what it takes to build a certain feature, or why some things are going to take longer than others, or what's actually involved, or why their request is unrealistic. And it's not their job to know. So getting frustrated or getting mad about the fact that, well, don't they understand this is a big deal? How come they don't appreciate how much work this is? They're just asking for all this stuff. Yeah, you probably do the same thing in your life of other people who do work that you're not familiar with, and it's just natural. People are going to ask for the moon and the stars. I want you to reconfigure the planetary orbits, and I need it done in a week, and I'm going to pay you 50 cents. That's sort of a natural thing. So your job, not necessarily. Your job, first of all, is to be honest with them and to set realistic expectations on their part, but your job is also to be a partner with them. So oftentimes they're asking for the moon, but the aspect of what they're asking for that's going to deliver the most value for them is much smaller than what they're asking for. So if you can focus in on what that thing is, and then you can deliver that in the constraints that they have in terms of time and budget, so they're getting the most value the soonest, then that's a good way of building trust and building a relationship. And understand that in our industry, trust is very broken. Trust between clients and managers and coders are very is frayed and very broken, and it's because they get burned all the time by coders who are giving unrealistic estimates. And it's not always the coder's fault. It's just as you know, there's a million things that can go wrong, and they often do. So when you're giving your estimates, the guideline that I use is, first of all, when you're asked to build something, break it down into tasks that are no more than a half day worth of work, and then take those, add up all of those tasks, all of those half days, and multiply by 3. and multiply by 3 if you believe you fully understand the requirement. You multiply by 3. If you believe there's some ambiguity around the requirement, you're not sure you actually understand it, then I would multiply by 5. And if you're really not comfortable that you understand what's being asked of you, then refuse to give an estimate until such time as you get more clarification. That's my general guideline. There's a lot about professionalism in a book, again, by Bob Martin, called The Clean Coder, and so I'll drop a link to that in the description as well. It's a great book about how to be professional and how to deal with this kind of stuff. And he has advice. He has a very kind of mathematical formula for estimates. I mean, I guess what I gave you is a bit of a mathematical formula, but he goes even deeper into it. I haven't used his method exactly, but the method I use is that 3 times, 5 times, get more info kind of pattern, and that's worked very, very well for me. In terms of some random other questions, there was a question about Go. What do you think of the Go programming language? So I haven't gone deep into Go. I've played with it. I think it's really interesting. I think the fact that it's cross-platform is very good. I think its focus on simplicity is good. I think its focus on parallelism is good, but I am more intrigued by a language called Rust, which came out around the same time as Go, and I kind of I wouldn't necessarily bet against Google. I think both these languages are going to find their place, but right now, just for myself personally, I'm more interested in Rust, and that's getting higher and higher on my list in terms of things to look into. Mozilla is working, I think, on rebuilding their entire browser and their entire engine using Rust. They're supporting it quite broadly, and they're quite vocal about their support. They're very excited about it. Lots of developers that I follow myself have talked about Rust and are excited about it. So I'm more excited about Rust than I am about Go. Not to say that either one is bad. It's just, that's my answer to the question. There was a question about what are prototypes and closures in JavaScript. And the question was around, like, is it important for me to learn that? My answer is absolutely. These are 2 probably of the most fundamental things to understand and deeply understand and properly understand about JavaScript. There's no way in a short amount of time I can give you a full course on prototypes and closures. But if you do read You Don't Know JS, that book, You Don't Know JS, you will get a lot of information about prototypes and closures. Does a really, really good job. Kyle Simpson, You Don't Know JS. But absolutely fundamental. Also, there's an article by Eric Elliott about closures in JavaScript, and he makes a pretty bold statement there. He basically says, if you don't understand closures, no matter how long you've been coding, you're a junior developer. Yeah, just very important stuff. So, and again, I'll put links in. I don't have time to go into a full description of what prototypes and closures are, but just know that they're fundamental concepts to JavaScript. And if you're criticizing JavaScript, before you criticize JavaScript, try to learn and appreciate the power of how closures work. There are bad things and good things about it. I got a question about security. How do I secure my apps? The first step to securing your apps is to set out to write secure apps, to care about security from the outset. A lot of times security is an afterthought and people don't think about it. And the guiding principle, obviously security is a big topic, but the guiding principle is just never trust any input that you don't have direct control over. So never assume, or actually another way to say it is, always assume that any input that's coming from the outside is evil and is looking to destroy your entire program, and treat it that way. So, SQL injection, cross-site scripting, these things happen because you're getting input into your program that you're just implicitly trusting, rather than explicitly asserting that they're not nefarious in any way. So that's kind of a guiding principle and a start on security. There's OpSWAT maintains a list of the top 10 web application security threats. It's a good idea to get to know what those are and understand how they impact your code. The other things I would say about that is, don't try to reinvent the wheel or write your own encryption algorithms, things like that. Use stuff that's out there, that's well known, that's well tested, that's robust. Don't store any information that you don't absolutely critically need to store within your application, information that can make you a target of attacks, of personal information, credit card information, login information, etc. If you can rely on third parties to keep that information for you, keep it out of your particular app. So that's what I would say about that. And so now we've reached the point where I'm ready to take some follow-up questions. So I'm monitoring. I think most people ended up on the YouTube channel. Most people have migrated over there. So I'm going to monitor the YouTube chat. So please feel free. I know there's a bit of a delay, but feel free to ask your questions there. So I'm just going to be monitoring, and yeah, I'll answer questions as they come in. So let me just write. Ask any. Right, so let's see. So yeah, once I start getting questions, what I'll do is I will answer them, and I'll, stick around. I'll try to answer as many questions as I can. So feel free to stick around. So does anybody have any questions? We're probably still on a delay, so. Okay, so yeah, so you're welcome. Okay, here the questions are coming in from you now. So you're someone said thanks for doing this. Yeah, you're welcome. I'm glad it's inspiring. Oh, so there's a question on ethics of being a coder. So I have some pretty strong views on ethics of being a coder. I wrote an article called "The Code I'm Still Ashamed of," and subsequent to that, I did a couple of great podcasts. So I was on Software Engineering Daily podcast and on the Code Newbie podcast, and I get into the ethics of coding. The Code Newbie one maybe it's a little bit more focused on ethics and on my particular story. So yeah, if you go to Code Newbie, just Google Code Newbie podcast. I'll put the link in the description. But yeah, check out the Code Newbie podcast that I did. I talked for about an hour on ethics, so I have lots of views on that. There's a question about Laravel. I have no real experience with Laravel. I don't know a lot about it, so I'm not a good person to answer that question. There's a question about Redux/Flux architecture. I'm in love. I'm absolutely in love with the ideas behind Redux. I like Redux a lot. I think it takes a very, very good approach to managing state within an application. I think it has, if you follow any of the best practices, it has some really, makes good use of functional concepts that are important. And by the way, we talked about the design patterns. So that Flux architecture or the idea of Redux where you're dispatching actions, that's called a command pattern. So learning the command pattern and having known the command pattern as I came to learn Redux actually helped me quite a bit. It's a state machine with a command pattern against it. So yeah, I like Redux a lot. I think it's great. I don't think it's necessarily the right tool for every single job. Obviously, you have to look at what the needs are of your project. If you're building a very tiny application that's not likely to grow very big, it may be overkill. It does add a lot of indirection to your code. The good part about that indirection is it makes things easier to reason about over time, and it keeps things nicely separated, and it makes them easier to test. Okay, so what do you think about PHP? My original feelings on PHP were very negative. I worked with PHP a long time ago, and I really did not like it. The slight contradiction there is a lot of apps that are built in PHP are apps that I use every day. And so obviously there's some value in PHP. And so I ended up sending out a newsletter called OMG PHP WTF. I've published that on my blog.devmastery.com, so you can go read it there. You can read my thoughts on it there. Basically, I point to an article from the company Slack where they talk about the maturity of PHP, and I think it's been very, very useful. Or sorry, not useful, but it's come a long way. So I would say that originally I didn't like PHP. I probably still don't love PHP, but I can see that there's a lot of value in it. Certainly a lot of people are doing cool things with it, so it's worth giving it a chance. So there's a question. We started unit testing, but we're getting bogged down with a huge object graph. So Yeah, let's think about that a little bit. Basically, you want to look to simplify, but sometimes if you have a big object graph and you actually need that big object graph, then the complexity is there no matter what. And so your choice is basically between, not having any automated testing around that big object graph, which is incurring you a much higher risk. And so you're going to pay for that down the road. So you say, oh, well, yeah, it takes a long time to write all these tests because we have, this big object graph and it's kind of hard to grapple with. So you don't write the test, and then your big object graph bites you in the butt because things start to break and you don't know where or how that's broken and you have no way of finding that. So you produce more brittle code, and so you pay for it later. And so you're much better paying the cost up front. And also, if your object graph is big, it's worth thinking about why is it big, and are there ways to decouple it without looking at your specific project. I can't give you more detailed advice than that, but yeah, maybe an indication that either it just is and that's the way it is, or maybe you've coupled things, or you've built things up bigger than they need to be. So there's a question: how do we learn best practices, industry standard code for any front-end framework? Depending on the front-end framework, and that's part of why I tell you to concentrate on frameworks that have the support of large organizations. They'll do a very good job of giving you tons and tons and tons of best practices. So to talk about some specific ones, so for Angular, there's a fellow by the name of Jon Papa. Jon Papa has done some great work around Angular and putting together an Angular style guide and putting together lots of videos about Angular code and best practices. So he's, if you're an Angular person, he's someone to follow. When it comes to React, and particularly when it comes to React with Redux, the creator of Redux, a guy by the name of Dan Abramov, is just awesome. He puts out tons of stuff out there. He has a course on egghead.io called Idiomatic Redux, and that's a great way of learning best practices with that framework. Okay, and the other question is: are we doing something wrong, or is it always going to be hard? It's always going to be hard. I'll put it this way: if it's not hard, chances are you're going to get bored. So at least in my career trajectory, I've always tried to make it hard on myself on purpose. But yeah, it is hard, and I find that it goes kind of in waves. There's a bunch of cool cartoons about it, but basically it's like, oh my God, this is so hard, I understand nothing. And then as you learn and learn and learn and learn, it's like, oh, I understand more, and then I understand more. And then you have like a aha moment where you're like, oh my God, this is great, I understand everything. And then just the one step beyond that aha moment, that I understand everything, is, oh my goodness, I understand nothing. There's so much to learn. I don't know anything. I suck. And then you go kind of back up. So it's this sort of roller coaster, and that's going to be the way it is for your whole career. So don't get discouraged by that. All right. Hard to build the object graph to test against data, not the database though. Mocked repos. Yeah. So there's a couple of things there. So there's different schools of thoughts around testing. So there's one school of thought around that your unit testing should be absolutely isolated from everything else, and you should never, ever, ever have a real database call in your test, because it's going to slow down your tests, et cetera, et cetera. I don't think you need to be that rigid about it. So if you have, I've actually in the past, I've used test databases that I can run a script and hydrate the database with my object graph and run a script and clean it up, and then test it that way, because that's less burdensome than having to mock out the entire object graph every time. I also, in a similar fashion, you can have a library where that basically has factories that can generate. You have functions that basically generate your object graph for you. You can know how to build the objects, and then you reuse that module that becomes reusable code everywhere. So it just emits those objects for you. Okay, love the 3 times, 5 times so how can you implement in a Scrum team that's not sharing the same scheme? Most of the managers are time crazed. It's hard to be defensive. Okay, so a Scrum team that's not sharing the same scheme. Oh, I see. So in other words, so other members of your team are not following the 3x, 5x principle, and you are, and so it causes this perception that, well, your time estimates are much higher than everybody else's time estimates, and so you must be wrong. What happens is the proof is in the pudding. So if you're using the 3x, 5x principle, you're going to end up doing what you say. You're going to say what you're going to do, and you're going to do what you're going to say, and you're going to produce quality code consistently, and you're going to be trustworthy. And over time, that's going to pay huge dividends over the person who's constantly underestimating. So yeah, at the beginning, the hero is the guy who says, "Ha, 3 weeks, I can do that in 1 week." And then everybody's like, "Whoa, this is the guy. He's going to do it in 1 week. Yes, let's give him the code." And then 1 week passes, and he can't deliver, or he's killed himself to deliver, or he's delivered something that's not working. Over time, that's going to catch up to that team member, and they're going to start to lose, lose their luster, lose their shine in the eyes of management and in the eyes of the project, because it's like, oh yeah, Bob says 1 week. Your manager's going to start to do it for him. Bob says 1 week, that really means 3. A 1 week Bob is a 3 week. Or Bob says 1 week, and that means that we're going to get something, but then it's going to be broken, and we're going to have to send it back to him 400 times before it works. Bill says 3 weeks, and at the end of 3 weeks, I get quality working code, and I can rely on that. I'm going to start going to Bill. So that's what I would say about that. Most of managers are time crazed, so it's hard to be defensive. Yeah. So there's two things there. So one is, you can't change the laws of physics. Things are going to take the time that they're going to take. If you have an hourglass and you flip it over and the sand is running down, you can scream and threaten that hourglass forever. It's still going to take an hour for all the sand to get down. It's just things take the time that they take. And so over time, if you're building a good relationship with your managers, and you're doing what I said, where you're actually delivering at the times that you say you're going to deliver, they're going to stop imposing timelines on you. But the other part of that that's important is you have to be good at asking questions to get to what is the actual value that they're trying to get. So what's the minimum, or what is it that you can implement within their constraints? So if their constraint is a time constraint or a budget constraint, what aspect, what feature, what can you actually do within that time and budget that's going to get them the most critical value, that's going to get them the most important thing? And that takes dialogue, and it takes time. You have to really get down to the bottom of things. And in the end, your manager is going to get, if somebody that's really hardly imposing timelines on you, and the timelines are impossible and unrealistic, they're eventually going to get burned, because you're not going to meet the timelines, and then they're going to have egg on their face. They may take it out on you, but it won't take long, if they're a good manager, to realize, you know what, they should just listen to you, and they would get into less trouble. If you're in an environment where the expectation is that everybody works 24/7, it's caffeine in, it's code out, everybody just sleeps under their desks and meets whatever insane deadline gets thrown at you, and that's just the culture, and that's the way it works. My advice to you is get out of that environment, because you'll eventually burn out, and that's an environment that's not really interested in you or in your career or in investing in you in the long term, because what they're doing is they're just burning through people. So they're going to bring in people, ride them hard, work them hard, and then as the people sort of burn out, get sick, become unreliable, they'll get rid of them, bring in new people, and keep doing at it again. And it's like a sweatshop mentality. Get out of there. We're in an amazing time where you can, there's an abundance of jobs and not enough people to fill them. So focus on that. Okay. So yeah, there's just a using entity framework is a question. So I'm just going to take a drink. I have a really strong dislike. Entity framework is in .NET. It's a class of tool called an object relational mapper, like an ORM. I have a really strong dislike for ORMs, because I find that they either give you a poor, you end up having to create a poor object model that supports a good data model in terms of normalization, and efficiency, or you're creating a poor data model that supports a good object model in terms of cohesion and in terms of ease of working with, but then you're trying to report on it, or you're trying to you're trying to work with the data in the same way and not introduce data corruption. You have big problems because the data was built around your object model as opposed to being built as a proper data model. The other thing with Entity Framework, I wouldn't, if you are using it, if you're in a project where you have to use Entity Framework and there's no like it's just a standard or it's just there, I would try to isolate yourself from it. So basically treat the objects that are coming out of Entity Framework as your data model, and then create your own domain objects and write an adapter between the two, so that as Entity Framework changes, or there's only, you can change along with it. As your models evolve, you only have to change code in one place in the adapter. And generally speaking, you know, at the beginning, Entity Framework and object relational mappers in general feel like a great time saving. They feel like you're getting rid of lots of boilerplate code and you can just iterate and go really, really fast. And then eventually what happens is all of that starts to really bite you. The limitations, etc., start to really bite you and start to cause you problems and start to cause you headaches. And the dependency on it is a big deal. So yeah, not a fan of Entity Framework. So let's see. What advice do you have for coders who may not have meetups, events in their countries, but would like to be involved in the coding community? So there's a Facebook group called Newbie Coder Warehouse. Free Code Camp has a huge community under Confluence. There's lots and lots of online communities. The other thing that you can do, another way to kind of get involved, is there's a website called codetriage.com, and it's a website where it has a bunch of open source projects, and so you can basically go there and they will surface for you bugs and issues in open source projects that need attention and that need work. And so by trying to contribute, or by starting to look at those bugs and starting to try to contribute value to those open source projects, you'll get involved. You know, just by virtue of contributing, you'll get involved in that community, and there's usually Gitter channels and Slacks, etc. that you can talk. Another great way to get involved in a community is a lot of online courses have a community aspect to it. So if you're buying an online course, you'll usually get access to a Slack channel or a Facebook group that's around that course. But then that'll be a gateway or an entryway into a community. Okay, so. After learning a language, how do we choose a next language or paradigm to learn? Apply my test. Learn languages that are highly marketable and broadly applicable. So after you've learned one language, move to another language that satisfies those criteria. So obviously you can't go wrong with Java, you can't go wrong with JavaScript. To a greater extent these days, you can't go wrong with something like a C#. These things are broadly applicable. You can do lots and lots of different types of code with it. They have concepts that are central to many other languages. So that would be my advice. In terms of keeping up with something new, I mean, I mentioned Rust earlier, but it's still early days. So Rust would be more of a kind of a passion project maybe at this point. It has good support, but it's not yet. I don't know that it's a hugely marketable skill or a broadly applicable skill. What's interesting about it, both Rust and Go, for different reasons, is it's interesting to see where the thinking has gotten to in terms of our industry, in terms of language design, and in terms of approaches to some common problems. Okay, so I think that's about it. Guys, listen, I want to thank you a lot for sticking with me, for being here. If for some reason you're not already signed up to my newsletter, you can just go to devmastery.com and sign up there. I think there's a form right as soon as you get there. All right, so there's a couple of more questions. I'll answer these. I'm going to go ahead and answer these. I don't have anywhere to be for a while, so I can keep going. What percentage of working time should be spent on code review? So code review is extremely beneficial. to an organization, even if you don't have, or to, not to an organization, but to you as a coder, also to an organization, but to you as a coder. So even if you don't have a formal code review process, even if you just have a buddy at work and you say, hey, listen, can you take a look at this thing for me, and I'll take a look at some other thing for you. Yeah, you're gonna get a really high return on that investment. So I don't know if to give you an exact percentage. Yeah, maybe 10% at a minimum on code reviews. The other thing is, and a lot of people don't know this, I'll try to stick the link in the video description. There's a Stack Overflow has a code review section. So there's like, Stack Exchange. So Stack Overflow is just one of a whole series of sites underneath the umbrella of something called Stack Exchange. So they have one site that's dedicated just to code reviews. I think it might be codereview.stackexchange.com, something like that. But yeah, so as long as you're not putting anything on there that's proprietary, that's going to violate kind of a non-disclosure agreement, if you put small code snippets there, or things that you're struggling with, you will actually get a lot of valuable discussion and a lot of feedback. And that can be useful if you're not in an environment where you have colleagues or coworkers that you can go to. So then, what percentage of working time should be spent on code review? Okay, I saw that. I'm not sure I understand. There's a question, what about 6 years of C++ experience? I don't know what that means. I don't know what that means. So I don't know how to answer that question. There's another question that's, what is your observation about not quite seniors? So people in their 40s and 50s looking to break into coding. So 2 things. 1, don't let the age thing discourage you, but 2, understand that the age thing is going to be a factor, and it's only going to be a factor. Well, it's going to be a factor in a couple of ways. So 1, you're going to the initial expectations are going to be off. So people are going to their initial impression or their initial expectation of somebody that's new to coding is somebody that's new to the workforce in general. But if you can demonstrate that you have the skills that they need, you should be fine. The other thing I would say is, it's really dependent on the context. Personally, I mean, I've hired coders my age or older, and they bring a lot to the table. Like people with experience outside of the coding realm or prior experience doing other things, I find bring a lot of value and bring a lot to the table. And I know that there are lots of employers that see it that way. But what can sometimes happen is, if people are looking for an employee for the long term, depending on how old you are or how old you seem, if they feel like you're very close to retirement or you're going to be retiring soon, they may not be willing to invest in you. But that's where going down a freelancing route might be a good idea. So going and not just necessarily freelancing like starting your own business, but freelancing through websites like toptal.com or crew.co, where basically you become part of a pool of talent that gets hired on a contract basis for short term to augment teams. And then in that case, your age becomes a lot less of a factor, and it's just about your skill set. But I don't think you shouldn't let age stop you. There's a great article, I don't remember what it's called, but I'll put it in the video description, by a 57-year-old who's learning to code, and it was put on Free Code Camp. I'll find it. I'll put it in the video description. It's very inspiring. Okay, so I have a question here. How do you feel about working at a company when there's no higher person in your department that you can be mentored by, particularly if you yourself are new to the industry, 1 to 2 years? Yeah, so I don't think, personally, I don't like being the most experienced person in the room. These days it's getting harder and harder, but yeah, it's always good to seek out places where you do have people who are better than you, who are more experienced than you. Having said that, sometimes you can learn from people who may have less experience from you. You can learn in 2 ways. 1, you can learn by trying to mentor and teach them. That's going to help your own understanding. And then the other way you can learn is that they may have less experience than you in general, but they may have more experience, or they may have touched one thing more than others. Yeah, and so that's what I would say about that. So for me personally, I would look for a place where you do have mentors, but even if you don't, there are ways to learn. So the comment here, the I'm learning to code at 56. Here's an epic beatdown to my critical inner self. That's exactly the article that I was referencing. It's on the Free Code Camp blog, and absolutely, yeah. Take a look at that if you haven't already. It's really worthwhile. Okay, let's see if there are no other questions. Yeah, I think we've gone pretty long. So listen, thank you again. Thanks everybody for joining me here. I will be I've recorded this, and I will be sending out I'll be sending out a replay or a recorded version, at least a YouTube link, so that you can watch this again at your own time. If you're watching the replay now, you're not familiar with DevMastery, just please go to devmastery.com, sign up for the newsletter. You won't regret it. I send out awesome stuff all the time. And again, like I said, I'll put a bunch of stuff in the video description. So yeah, thank you. Thank you. Sorry. Thank you so much for your participation today. Have a great day. Thank you.